Okay, so in this video, we are going to discuss one simple circuit that looks like this. So there will be, sorry, two impedances. Here it is supposed to come like this, and which are connected in series. And then there will be, let me undo, two voltage sources. It looks like a bus. So V1, V2. So let us spend today's this session only discussing this. Okay? So they'll give some values. So 100 volts with 0 degrees, and let's say 150 volts with some different angle. So let's say minus 30 degrees. So now, what can be the values of Z1 and Z2? Can you suggest? So some impedances in ohms. Okay, let us make first one as inductive. So maybe 10 ohms plus J 5. So this is in inductive impedance, and this one let's make it 8 ohms minus J. Let's make it 8. Okay. Let's make the current total as I itself. So I have V1, V2, but there is no I1, I2 because it's a series circuit. So there is only one current here. Did you all understand the circuit? Any questions or any doubts on the circuit, how it is coming? Okay, so now today's subject I wanted to talk about vector diagrams. So I'll change the color to maybe blue, and if I draw a horizontal line, okay, and call it, what should I call this one? What this represents? So it will obviously represent V1, which is 100 units, 100 volts, and V2 is minus 30 degrees. So it will be slightly under this, but then the length will be more. Okay, so V2 here will be 150. Okay. So now can you tell me what will be the current I? So unless we calculate, we cannot tell, right? So let us use the this vector diagram to represent voltages and currents. So normally impedances are not shown in the vector diagram. Only the voltages and currents are shown. So how to find I? Can you quickly tell me the steps to find I? So let us define the inputs. V1 equal to V2 equal to Z1 equal to Z2 equal to. And once I define these things under the calculations, I will get I equal to total impedance divided by total, sorry, V by, so total voltage. So V1 plus V2 divided by Z1 plus Z2 will give me the total current. Let's label it as capital I. Now, how do we represent this one? So we are talking about Python language in which we define the complex number. So how do we define? So complex, and then I give the real and imaginary parts. Okay. Z1 is 10 plus J5, so 10 comma 5. Complex 8 comma minus 8. Okay, so that was the impedance Z2. Now, because V1 is given in polar form, 100 with angle 0. Anyway, so in this case, it is same as 100 comma 0, because the whatever 100, because it is 0 degrees, it all comes in the x-axis only. So I can give like this also. Both are equivalent. But here there is I need to use a different one. I think cmath dot rect. Okay. So this will give the rectangular value given the phase, I mean the length and the phase. Okay. 30 degrees, right? So minus 30 degrees divided by 180 multiplied by pi, math dot pi. So the second element will be the angle in converted in radians, and the first one is the length of it. Okay. So yesterday I was seeing there is this for printing. See, if I want to print the voltages V1 and V2, okay, so there is this F string. If you see on Monday's class, I used V1 equal to, then again brackets, and then again I say V1 dot 2F, something like this with colon. So what is the meaning of this? Uh, I'm starting with a label V1 equal to, and then I'm giving the value V1 with the two decimals. Okay? That was the meaning. But I yesterday I was seeing on YouTube, there is a shortcut way of doing this. I will keep. There's a shortcut way of doing it. So simply, I can remove this and then say equal to here. Okay? So equal to with either side. This here I will use V2. Okay? So just I will print this and see what happens. I have given name b.py. Okay, no, it is not working. What it's supposed to do is it's supposed to repeat this because I ended with equal to. Anyway, so I need not. I'll go back to our old notation. So V2 equal to V2 0.2 F. So let's Z I will not print in the interest of time. So I will go for printing I equal to. So so I got the answers now. So V1 100 plus J0, you all agree to that. V2 is 129.9 minus 75. Okay. That is because 30 degrees, right? So I'll tell you one more way to do this. See, this angle is 30 degrees minus 30, or so if I'm interested in the vertical component, which is equal to vertical component here in the triangle, what is sine of 30? So sine 30 is 0.5. Okay. So 150 into 0.5, 75. Okay. So that's what you see here in the answers. Minus 75 it is coming. So it just confirms, and then 129.9, maybe that is cos of 30 is 0.866 something, or and then it's multiplied with 150, it comes like that, but that is fine. But more interestingly, here I got the I 13 minus J 1.98. That means what? The the current is lagging because the second component is negative. Okay? I want to know the angle of the current. So let's calculate that. I go here and let's calculate the angle of the current. So how do I calculate? So IA, and then in fact I can directly print it here. So first absolute value of I will give me the current. Okay, then I'll use this angle symbol just to make it look like angle. And now I want the angle of I. How do I get that? I think, did we use that yesterday? There is a phase, cmat dot phase. I need to give round brackets, cmat dot phase of I. This will be in radians, so we need to convert to degrees. So d mat dot pi. Now this whole thing I want to round off to point 0.2 float. Invalid syntax. Let's just I think this underscore might be a problem. Otherwise, what about now? So IA is the angle of A, angle of I, cmat dot phase of I into 180 divided by mat dot pi. At least this should work, right? So then I will come here. Sorry, I forgot the closing bracket there. This may not be needed. How about now? One last I have to remove this. Is this correct now? Let us see. Yeah, I'm getting. So minus 8.61 degrees for the current. 13.252. There also I can format the number of decimals. Let's do that. Point 0.2 float. So 13.25 angle is minus 8.61 degrees. So again, everybody clear with what we did so far? So now I will draw this in the our phasor diagram. Okay. So for current, let me use red color. So now I can use a different scale for currents and voltages. So this is 13.25 at an angle of minus 8.61 degrees. Okay. So everybody is fine with this? This can be resolved into horizontal component, vertical component, and already you know those things. Now, next question I can ask is, what is the voltage across Z1? How much voltage is dropping across Z1? Even before that, I can ask another question. What is the total voltage applied to the circuit? What is the total voltage applied to the circuit? The addition of these two vectors, okay, this one and this one. So let us do that first. Okay. So I'll go back. So instead of here, Vt equal to V1 plus V2. And here I will replace Vt. Now that Vt I want to uh, print it. So I'll just copy this, and here the above line I will change. I'll say Vt equal to. So this one will give both real and reactive components. Then here I will change it to Vt absolute value and then the angle. Now the code is ready. So can you guess now what will be the. See, you know the parallelogram, right? So when you add two vectors, you attach the second vector to the end of the first vector. So I can attach this V2 here like this. Let's go back to blue color like this, or this one also. In other words, V2 I am attaching the V1, something like this, and here I get a point like this. Okay. So again, please focus here on this. So that will be the total. Can you, so let's see what will be the thing. What, I did not save it. Okay, I think the issue with capital V and small v. So here, yeah. So I use capital V everywhere. In the second line of the result, you find the total voltage. Happens to be 241 volts with angle of minus 18 degrees. Okay. So that is the total voltage. So let's draw that. This is Vt. Okay. 241 angle is minus 18 degrees. So really utilizing the formula of the slide also. Yeah. So now, what can we draw next? We can draw what is the voltage drop of Z1 and what is the voltage drop of Z2. Okay. So let us do that. Okay. Under the calculations, I want to calculate VD1, that is voltage drop of 1, VD2, the voltage drop of 2. Okay. So what are these voltage drops? Nothing but total current. I can do I into Z, Z1, and total current into Z2. Sorry. So again, any anything difficult here? I'm just multiplying the current with the impedance to find the voltage. Okay. VD1, VD2. Okay. So now I'll copy the second line and go to the last. So let's make it D1, D1. So first it will print in real and then polar. Okay. So here 2. So anything again, any doubts here? You are able to follow, right? So let's see what this VD1, VD2 will look like. Okay. Can you Can you guess what will be the VD1, VD2? I will show that separately. Anyway, let's draw it. Let's find out the values. Then we will see. So I'm getting something like this. Okay. So 148 and 149.9. These two in two different angles. So since there are too many vectors, let us draw these two. Okay. I'll go to the second page. Just for our review, let's draw a little bigger. This used to be our original voltage source 1. Then we had a 30-degree angle with voltage source V2, which was 150 with angle of minus 30 degree. And then the addition of these two, we got somewhere here. The total voltage V of 241 with an angle of minus 18 degrees. So now we got two more things. So let's change the current color. So what is VD1? 148 with angle of almost plus 18 degrees. I round it off to 18 degrees. Okay. So let's do that. VD1 149 or 8 148 angle of 18 degrees. And what is VD2? Again 140, or I'll round it off to 150, but this time the angle is minus 53 degrees. So this one we already know it is minus 30, so it will be somewhere here like this. VD2 is 150 angle minus 53 degrees. Okay. So what is going to be my next statement? So the voltage drop across this is VD1 and the voltage drop across this is VD2. So what's supposed to be VD1 plus VD2? VD1 plus VD2 supposed to be equal to total voltage. Okay, so now you can actually add them. Uh, Here also graphically we can see if I take this VD2, attach it to the end of VD1, it will match with the total V. Similarly, if I take VD1 and attach it to the end of VD2, again it should match with that one. Okay. But since graphically we are not doing, I can always do like this. Okay. So I can go here. I'll say sorry, VDT, VD total is VD1 plus VD2. And then I can copy this and then paste it here and then make it. So again, you're following, right? Is it? Yeah. So you will see line number 2 of the result and line number whatever last line also matches. So now we have maybe 2-3 minutes. I want to find the powers. Okay. So what is the power? So power is P plus JQ, right? So here under the calculations, I will write S1 equal to S2 equal to. So this is the complex power consumed by impedance 1 and the complex power consumed by impedance 2. Okay. So how do we find that? So what happens is here I square into Z we can do. Okay. I is common for all, right? So simply I will say absolute value of I square multiplied by Z1 will give me the Z1 is complex, so S1 also will be complex. Okay. Absolute value of I multiplied by I mean square into Z2 will give me this one, and ST is S1 plus S2. Now let's go ahead and print that. So print formatted string S1 equal to S1 with two decimals, S2 equal to S2 with two decimals, and ST equal to ST with two decimals. Okay, so ABS somewhere here. Okay, so you can see the total power consumed by the first impedance is 1756878. Okay. Now this is reactance, so that's why it is a positive J. Okay. Whereas the S2 is 1404 and here it is negative minus 1404 because it is capacitance. And the total source, actually you notice the total source is consuming the reactive power, whereas supplying the active power. So again, I hope you're okay. You got this. Okay. What is the other way to find the powers? Okay. So I know V1, V2, right? So here S1, I will say S1A and S2A. Okay. Just A means alternate way of calculating, right? That is V1 into conjugate of I1. Okay, so I don't know how to find the conjugate. Is it like this? Let's see. And ST alternate way is nothing but S1A and plus S2A. So this is another way to calculate. So I think the next class is there. I'll just stop in 1 minute. So let's search. CO in J, no, not NumPy. Anyway, I think I will leave it as a homework for you to check. So I hope you got some idea about drawing the vector diagrams using this. So with this, I will end the class. Thank you.